Okay, so welcome back, and now we're going to do this example here. And so, again, what I'm going to do is I'm going to use the test here. So we've got this power series, x to the n divided by the square root of n. And so what I'm going to do is take the ratio and see what we get. Okay, so using the ratio test, again, for all values of x, so I'm going to use the absolute value just like before. So the limit as n approaches infinity of the absolute value of, so we're going to have this, so on the top we're going to have, x to the n plus 1 over the natural log of n plus 1. And then on the bottom we have x to the n over the square root of n. And so this is going to be the limit as n approaches infinity, right? So again, what are we doing this for? Is we're looking for absolute convergence. And so now this is going to become the absolute value of, this is now going to be, x to the n plus 1 over the square root of n plus 1 times the square root of n over x to the n. Now, again, notice that this is going to cancel with this, so we get an x on top. And then notice that we get a square root that we can combine. So this is going to be the limit as x approaches infinity of what? I'm going to split this up into the absolute value of x times the absolute value of, well, these are all positive, so I can drop the absolute value for these. So this is going to be the square root of n over n plus 1. Okay, now, what's happening to this thing? Well, this is going to be equal to the absolute value of x times the limit as n approaches infinity of the square root of n over, well, let's split this up. No, we can't. So n over n plus 1. Okay, now, what is this going towards? This is going towards 1. This is getting closer and closer to 1. The limit of this is 1, so this is going to be the square root of 1. And so what do we get? We get the absolute value of x. Okay. So what does that mean? Well, this is convergent if it's what? Less than 1. So this converges, so the series converges when the absolute value of x is less than 1. So that means the interval of convergence is -1 to 1. And that means the radius of convergence is 1 also. And there you go. Now, what about when x is 1? When x is 1, when x is 1, you get 1 over n to the 1/2, which is a p-series where p is less than 1. And so when p is less than 1, what do you have? You have a divergent p-series. Okay? So when x is equal to 1, it's divergent. What if x is equal to negative 1? Well, negative 1, you get negative, right? So if x is negative 1, you get which is a harmonic, well, not a harmonic, but it's an alternating series. And if you take the absolute value of this, you get a p-series that's divergent. Okay, so it's not absolutely convergent when x is equal to negative 1 as well. And so this is where it stands. Have a great day.